As a former high school math teacher and in my current role as an instructor for math teachers, I've encountered many myths about learning mathematics. Let's take a look at my top three math myths. It's time to debunk these fallacies. The first myth is likely one you've heard often as well. Some people have a math brain and some just don't. Well, in society, the I'm just not good at numbers or I'm not a math person mentality is almost a badge of courage. How can this fixed mindset possibly encourage children to be confident when learning math? Well, it doesn't. The truth is, there's no such thing as a math brain. I know, you're thinking, what? How can this be true? So, research continues to prove that students can learn math when taught effectively. In fact, only 2 to 3% of people have such significant learning disabilities that they can't learn math at the highest levels. Okay, so what does it mean to teach math effectively? It means providing opportunities for students to make mistakes when visualizing complex problems. As a matter of fact, when mistakes are made, the brain grows. This concept is in alignment with Vygotsky's research on zone of proximal development, as well as the research going around growth mindset. Therefore, it's easy to see that when students have a growth mindset, they are more likely to develop a deep understanding due to the mistakes made along the way. So, it's just not true that you're born with a math brain or not. The truth of the matter is that learning math has more to do with the experiences students encounter to authentically solve problems, make sense of numbers, and persevere through mistakes. In that case, how might teachers provide these rich learning experiences? Well, hold that thought. Before we go there, let's take a look at myth number two. So, brain research has uncovered another belief, a myth that keeps many children from succeeding in math. Most mathematics classrooms in the US equate skill with speed, valuing fast recall and testing even the youngest children against the clock. But studies show that kids manipulate math facts in their working memory, an area of the brain that can go offline when they experience stress. We now know that some of our best mathematical thinkers are often those most negatively impacted by timed testing. Time tests impair working memory in students of all backgrounds and achievement levels. Anxiety over time tests negatively affects achievement results of most all students, especially in mathematics. Time tests are also linked to the early onset of math anxiety. By some estimates, as many as a third of all students, starting as young as age 5, suffer from math anxiety. And students who were exposed more frequently to time tests performed more poorly towards knowing facts from memory than those who were not. Some of our world's leading mathematicians are not fast at math. The truth is that students become more confident and develop fluency when provided the time to make connections between new concepts and what they already know and understand. The fact of being quick or slow is just irrelevant. In my experience, I've seen that many teachers faced with long lists of content to cover to satisfy state and federal requirements worry that students do not have enough time to explore math topics in depth. Others simply teach as they were taught. And few have the opportunity to stay current with what research shows about how kids learn math best as an open, conceptual, inquiry based subject. These obstacles provide the perfect storm for teachers to believe that the best way for students to learn math is to memorize rules and procedures. But what we know now is that that's a myth. We all know that what is memorized is forgotten, especially if it's not connected to what we already understand. Unfortunately, memorization often comes without understanding. The foundation of the foundation that all math students need is number sense. Essentially, a feel for numbers with the agility to use them flexibly and creatively. A child with number sense might tackle 18 times 5 by connecting to an easier problem. Students without number sense could arrive at the answer only by using an algorithm. So, to build number sense, students need the opportunity to approach numbers in different ways and to see and use numbers visually and to play around with different strategies for combining them. Consider the three different thought processes and solution paths for Sarah, Jordan, and Brock when thinking through the product of 18 times 5. Sarah recognized that 18 times 5 is twice as big as 9 times 5. So she thought of it as if she knows 9 times 5 and doubles it, then she'll get the correct answer. Jordan chose to think of 18 as 10 and 8 and multiplied each of those by 5, then added them together. Brock instead recognized that 18 times 10 is twice as big as 18 times 5. So he mentally computed 18 times 10 and then halved it. So let's now take a look at an example with fractions. First, a procedural view and then a conceptual approach to understanding the procedure. For many, math is learned as a series of steps to be memorized and repeated over and over. You may remember learning a process like the one below for converting a mixed number into a fraction. So, first, you multiply the whole number by the bottom number or the denominator. Next, you add the top number, the numerator, to that result. And then finally, you take that result and put it over the original bottom number or the denominator. Now, let's see how it looks for students who understand a process and use a process that they already know what to do. So, first of all, a student might think of 4 and 2 fifths is 4 plus 2 fifths. And then knowing that 4 is actually just the same as 20 fifths. So 4 and 2 fifths is the same thing as taking 4, written as 20 fifths, adding that to the 2 fifths, and we have 22 fifths. Students who understand fractions this way are likely to discover the traditional algorithm on their own, and it's much easier to remember something you've discovered. Memorization, particularly when it comes to formulas and algorithms, is almost always unnecessary for the student who thoroughly understands a few basic concepts. These students can apply what they know to a broad range of problems and situations. So, math is not about knowing how to move numbers around on a page in a certain order and applying different operations. Students learn to become mathematicians when they have many opportunities to practice making sense of numbers and operations, and then applying appropriate strategies to solve problems. Now, let's consider these three truths uncovered. First, anyone can learn to be a good problem solver in mathematics. Second, being good at mathematics is not equivalent to how fast you solve problems. And finally, making sense of numbers is more important than memorizing facts. In the words of Joe Bowler, if teachers present math as a visual subject and one that is taught through creative inquiry and accompanied by growth mindset messages, then more students will engage with math's true beauty. An obvious outcome is that assessment scores would rise, and more importantly, our society could tap into the unlimited mathematical potential of our children. If you'd like to know more about math myths and uncovering those, then follow me at Jenny Ray at leadforwardllc.com.